Alright, here in this is the second part of the Chapter 5 review, or the review up till now, 5.1 to 5.5. Starting with 17, find the exponential function that satisfies the given conditions. Initial value 35, increasing at a rate of 15% per year. So let t equal number of years. Alright, and then we've got y equals 35. It's always the initial value times 1 plus, because it's increasing, the rate of growth, so 0.15 to the t power. Alright, and then this simplifies down to just y equals 35 times 1.15 to the t. Alright, so there's our answer. Alright, 18 is a continuation of 17, so we're still doing the same thing. Initial value is 54, but now we're decreasing at a rate of 0.43 per week. Alright, so now t is number of weeks. Alright, and our equation will initially look like y equals, again, the 54 is our initial value times, this time because we're decreasing, when we multiply we're going to subtract from 1, changing this to a percent, so 0.0043. Alright, and then to the t power, again, where t is number of weeks. So we end up with 54, and then 1 minus 0.0043 is 0.9957 to the t power. Alright, so our equation would be y equals 54 parentheses this 0.9957 to the t. Alright, so it's always initial value times either 1 plus or minus the rate, and again, if it's increasing you add the rate to 1, if it's decreasing you subtract the rate from 1. Always change that rate to a decimal though. Alright, number 19, find the amount of money in an account after 5 years if $1,400 is deposited at 5% annual interest compounded monthly. Alright, so we've got y equals, or sorry, they like us to use s equals instead of y for these types of problems. So s equals, this is our initial amount, so this goes out front, 1,400 parentheses 1 plus. Now this is what I was talking about a couple videos back. This is the only time that we actually leave the 1 plus. Like up here we actually subtracted it, but here, because this 5% is compounded, we change it to a decimal, we divide by the number of compounding periods, so 12 parentheses, and then it's the number of compounding periods times the number of years, so 12 times 5. Alright, so this is what I'm going to put into my calculator, 1,400 parentheses 1 plus 0.05 over 12. You put that in your calculator, 0.05 over 12 alone, and hit enter, you get a decimal that repeats, and here we want to try to avoid that if possible. We want to only round one time at the very end. So this is what's going to go into my calculator. So 1,400, I'm going to do it exactly like I see it, so parentheses 1 plus 0.05 divide by 12, close parentheses, raise it to the 60th power. Alright, I get 1796.70. This is money, so round it to 2 decimal places. Make sure I did that right. 96.7, okay. Alright, so this is how we would do that. Again, the formula I'm using here is S equals P times 1 plus R over K to the KT that we used, or that we introduced a couple sections ago. Okay, S is the amount of money after the T years. P is the original principal, the amount deposited. R is your interest rate as a decimal, and then K is the number of compound periods in a year. Alright, so because of monthly, that's why K is 12. Alright, so that's the formula that I'm using here in this problem. I'm not just making one up or anything. Alright, then number 20. What will the amount in an account with initial deposit or initial principal 5,000 if the interest is compounded continuously at an annual rate of that for 8 years? So for continuous compounding, we're using a little bit different of a formula. We're using what I call the PERT formula. Alright, so this E is the button on your calculator, the number that's similar to pi that we talked about. But S equals, P is our initial principal, so there's P. So that $5,000 is our initial principal. So 5,000 times E to the R is this as a decimal, just like before, so 0.0425, and then T is 8 years. Alright, and I can just put that straight into my calculator. So 5,000, clear it, 5,000. There's the E button above LN. So second LN, and then just type exactly what you see here, 0.0425, alright, times 8. So I get $7,024.74 to 2 decimal places. Alright, so that's the review up till now. A lot of different properties and things that you got to get down, but some of it is simply just plugging into a formula like these last couple of problems. So a lot of stuff to practice, but once you practice it enough, you'll get it down.